So let's take a look in detail how the classical seasonal decomposition method works. So rather than using stats models and the built-in function seasonal decompose, we're going to look at how additive and seasonal multiplicative seasonal decomposition works. So we've got some standard imports, pandas, numpy and matplotlib. We're going to look at both the ED dataset and the alcohol dataset. So let's bring in the ED data and do a calendar adjustment. Let's just check how many we've got in there. So it's 98 in length. So seasonal decomposition breaks a time series into components, into trend and seasonal components. So some people have used this for forecasting itself. My advice would be to use it for understanding the trend and seasonality within your time series. And in particular, seasonal decomposition works with monthly or quarterly data. If you've got weekly or higher frequency data, you'll need to use a different type of seasonal decomposition. So two types, additive and multiplicative. Additive is where the variance of the data doesn't increase with the level, and that means that we can assume that our observed value is a sum of the trend, the seasonality, and a random error. In multiplicative decomposition, we assume that the variance increases with the level of the data. So our observation is the trend multiplied by seasonality multiplied by the error. So we're going to look at how you do a seasonal decomposition manually, so we understand exactly what's going on. So the good news is this is very easy to do, very quick and easy. First of all, we're going to look at additive seasonality. And then there's some extra information in the notebook where you can work through a very similar example with multiplicative seasonality. So the first thing we'll do is we'll create a data frame called decomp, and we're going to store all of our components within that. So we'll start off storing the actual value in there. So we're going to store the arrival rate in there. And then what we're going to do to estimate the trend within the data is we're going to create, because this is monthly data, we're going to create a 12-month centered moving average. So we've seen how to create moving averages before. We just used a rolling method off a data frame. We pass in the window that we want to use, and for a centered moving average, we just set the center parameter to true. Let's run that and we'll take a look at that so you can understand what a centered moving average looks like. So you can see here there's missing time series from the smoother at the start and the end of the time series. And that's because it's a centered moving average. So that's our trend component, and that's exactly what stats models would estimate for us from this data. So once we've got an estimate of trend, we can do something called detrending. And that means we're basically removing that upwards trend from the data. And in an additive model, that's really straightforward to do. We just look at our equation and then move the trend over to the other side and subtract that from the observed value. So if we subtract the trend from our observed value, we're left with the seasonality plus the error. So to do that in pandas, we can create a new series by subtracting the trend column from the actual column. And then when we plot this, what you can see is that upwards trend has now been removed. And what we have is the seasonality plus some random error within there. So to calculate the seasonal indices is also very straightforward. The first thing that you need to realize is that classical decomposition assumes that seasonality is the same year to year. That means for each month we're going to calculate a value, and that's going to be the seasonality for that month in any year of the data set. So we're going to work with the detrended series, and all we need to do is group that series by month. So if you like, that will give us a series of rows, and on the columns across the top are the year, are the month, and the rows are the year. And what we're going to do is take the mean of those columns, and that will give us the average seasonality for that month. And that's what this bit of pandas does here. So on the detrended series, I'm calling the group by method, and I'm going to group by month, and I'm going to take the mean value. So let's plot that. And here is our monthly seasonality. So we can see that in January, it's about 20 on average below the mean. In February, it's about 5 below the mean. By the third month, it's above the mean. It's about 8 above the mean. And there's a peak of just over 10 in the 7th month of the year. So that is the typical seasonality we're seeing within the ED data set. So that's useful information. That helps us understand the seasonal fluctuations within a year. So we'll need to, so that's only 12 data points. We need to turn that into a data point per row within our time series, within our decomp data frame. So to do that, we can use something called the map command. So for each month of the year, I'm going to map the seasonal index across. So if we run that and then take a look at the data frame, I'll explain what that's done. So we can see for the 4th month of the year, if we read up and across, that's about 4. And then when we look down here, what that's done is it's mapped across that value there. So it's a bit like a VLOOKUP within Excel. So it's looked to our smaller table of seasonal indexes to find the month value within there, and then it's inserted that into that column for us in this single neat statement. Okay, so now we've got our actual, our trend, and our seasonal. Now we just need to calculate the residual, the remainder, the irregular component. So we do that by just subtracting the trend and the seasonality from the observed. And whatever we've got left is our unexplained remainder. So here, this is how you do that in pandas. So it's all within one data frame. So it's just our actual minus our trend minus our seasonal components. And that gives us our what we've called our residual, resid. So we can look at all of that in a seasonal decomposition plot. So here we've got our actual, our original time series. Here we've got our trend cycle within that. Here we've got our seasonal components by month. And notice, because it's additive, that's an absolute value ranging between -20 and 10. And that's just how far you adjust your series above and below the mean trend. And then we've got our unexplained remainder within the series. So as a side note, what this process allows you to do is then seasonally adjust your data. This tends to be something that's done in economics. When you see published time series, they tend to be seasonally adjusted. So all we're doing here is subtracting the seasonal component from our observed, and that just leaves the trend and the error. So if we run that and then take a look at it, that's what the ED data set looked like originally, and this is what it looks like with the trend removed. So there's still some you can see the trend in there, for example, that goes like this, but then there's still some wiggle in there from the error. But that's a seasonally adjusted time series. So if you see that, if you're looking at any sort of time series online and it says it's seasonally adjusted, it will have gone through some sort of process where it's estimated the seasonal indices of the data and then if it's additive seasonality, subtracted that from the observed value. So the rest of the notebook looks at multiplicative seasonality. So I'm going to let you work through that on your own. I'll just bring the data in. So you can see it's the data set you should be well aware of now, which is the alcohol data set. And you can see that this has multiplicative seasonality as the variance of the data increases as the mean level of the data does. So we go for exactly the same process there.